All right, today we are going to talk about the reason why the masses on the periodic table are not whole numbers and something called the average atomic mass. So we're going to learn about average atomic mass and how to calculate that today. So pay attention. We're going to get into math. I'm going to do some calculations. This can get a little complicated if you're not paying attention. So make sure you follow along with the examples that I'm going to do. So let's review some stuff that we talked about last time. The mass number is the number of protons plus the number of neutrons. Your atomic number is the number of protons. And an isotope is the atoms of the same atomic number but different mass numbers. And isotopes are the reason why we're doing what we're doing. Okay. So each square on the periodic table gives information about the elements. When you look at the periodic table, each square gives information. Some periodic tables are going to have more information than others, but they're all going to have, all periodic tables will have the information I'm going to show you right now. You have the symbol, which is either a capital letter or a capital and a lowercase letter. You have the atomic number, usually at the top of the square, and you have the atomic mass, usually under the symbol. So you've got the symbol, you've got the atomic number, and you have the atomic mass. Now, the atomic number is sometimes in the left corner, sometimes in the right corner, sometimes right in the middle. It's usually at the top in most published periodic tables I've seen. But the one that has the decimals, that's our atomic mass. Notice I said atomic mass and not mass number. Mass number is the sum of the protons plus the neutrons. Atomic mass is this number on the periodic table. So mass number, number of protons plus neutrons. Each element also has two or more isotopes that exist in nature. So some isotopes occur more abundantly than others. So pretty much every element has more than one isotope, more than one version of itself. Some have up to 8 or 9. Most of them have 2 or 3. So hydrogen is 99% of all hydrogen in the world is hydrogen 1, which means it has 1 proton and 0 neutrons. It's just a proton with an electron. That's what hydrogen 1 is. 99% of all hydrogen is hydrogen 1. Hydrogen 2, which would be 1 proton and 1 neutron, hydrogen 2, and hydrogen 3, which is 1 proton and 2 neutrons, make up the remaining 1%. So 99% of all of it is 1. So if we were to just do an average of their masses, 1 plus 2 plus 3 is 6, divided by 3 is 2. So if you just average those masses together, you get a mass of 2. Well, that's not accurate because 99% of all of the hydrogen is 1. So we give it special attention. All right. The different isotopes of the elements, the mass on the periodic table is a weighted average because some isotopes occur or are more abundant. They occur more. There's more of them. So hydrogen 1 makes up the majority of all hydrogen in the galaxy and in the universe. And so therefore we give it a weighting to its average. Now you should be familiar with weighted averages because it means one thing occurs more or has more weight. It matters more. That's why we give them a weight. Weighted average means that one isotope occurs more, its mass is given more weight in the average. You're familiar with that because your grade is a weighted average. Now, in your grade, daily grades are worth the same as test grades, but you'll notice you have a lot more daily grades, but they're weighted the same as a test grade, so you have a weighted average. So one test grade makes a much bigger difference to your grade than one daily grade does because you have like 8 or 9 daily grades, but only one test grade. And so your daily grades each individual daily grade doesn't matter as much as a test grade does. So it's a weighted average. So to calculate the weighted average of atomic mass of an element, you need to know the mass number and its abundance. You need to know its mass of the isotope and how much that isotope occurs. Now, I'm going to tell you the abundances. You don't have to memorize those or calculate those. So if the abundance is given as a percent, then you're going to change it to a decimal by moving the decimal 2 places. I will show you how to do this. I'm just giving you the steps first. Then after you have change your abundance to a percent, you're going to multiply the mass number of each isotope by its abundance. So you take the mass times its abundance and get an answer. Then you take the second isotope, mass times its abundance, and you get an answer. You do that for each isotope. If you have 5 isotopes, you do it 5 times. If you only have 2 isotopes, you do it twice. And then you're going to add all those answers together. And then you're going to round it to 5 digits, not 5 decimal places, but 5 total digits. And I'll do some examples and you'll see how this works. So we're going to give this following information about copper. I'm going to give you all the information, and then I'm going to switch to my document camera and work out how to do it. So here's all our information. We have number of protons, 29. They both have 29 protons because they're both copper. This is copper 63, which means it has 34 neutrons, because 29 plus 34 is 63. 29 plus 36 is 65. So there's 36 neutrons. The mass number would be 63. That's it right there. And 5, or 65 right there. Now, abundance. We know that in nature, copper 63 makes up 69.17% of all copper, and copper 65 is 30.83% of all copper. So this is the information we have, and really this is the only stuff you need to know, the mass of each isotope and its abundance. Once we know that, we can calculate the average atomic mass of. So I'm going to go switch to my document camera now, and we will work out how to do that.
So let's look at this example that was in your notes. We have copper 63 and copper 65. Now, your notes told you that copper 63 was 69.17% of all copper, and copper 65 is 30.83% of all copper. Now, the first thing that you are supposed to do is to change your decimals into, or your percentages into decimals by moving the decimal 2 places to the left. So I'm going to do that. Now, you only do this if it's a percentage. So that means I have 0.6917 and 0.3083. All right, so the second step is to multiply our mass times our abundance for each one of them. So I'm going to do 63 times 0.6917 and 65 times 0.6 or 0.3083, and I'm going to get answers. So let's go ahead and use our calculator, which you can't really see that, so I'm going to use it anyway. So I've got 63 times 0.6917 equals. Now my answer comes out to be 43.5771. That's what my calculator gave me. So then I'm going to do the same thing here. Now I'm going to do 65 times 0.3083, and that gives me an answer of 20.0395. So I took my mass, multiplied it times the abundance, and got an answer. I took my mass, multiplied it by my abundance, and got an answer. Now the last step, or step 3 on your notes, said to add these together. So I'm simply going to take my 43.5771 and add, so plus 20.0395. I add those together and I get 63.6166. Then I want to round to 5 digits. So start all the way over here on the left and count 1, 2, 3, 4, 5. So this is my 5th digit, so I'm going to round to right here. So if I'm rounding to here, then I need to look at the number next to it. The number next to it is bigger than 5, so it disappears, and this gets bumped up to a 7. So my answer is 63.617. all right? You need to make sure that you round correctly. Always round to 5 digits, and make sure you know how to round properly, because if you round incorrectly, you're going to get wrong answers. On a lot of these assignments, if you do the problem correctly, you will get exactly the same answer that I get whenever I do it. So you need to make sure that you do it. So if you don't round properly, you will get the wrong answer. So make sure that you round properly. I'm going to do another example real quick here. So go ahead and pause the video so that you can write this down and follow along. So go ahead and pause this. All right, so now that you've gotten it written down, you'll notice that I have atomic masses. Now these are not whole numbers because these are using something called AMUs, atomic mass units, which are the actual masses of the things, not the relative masses. We're not really going to get into all of that much, but you will oftentimes see the masses given to you in atomic mass units, which are going to give you some decimals. Don't be freaked out by that. It just pay attention to how it's labeled. That's your atomic mass. This is our abundance, all given to us in percents. So the first thing I need to do is for each one of these, I need to move my decimal 2 places. So this one's 0.04345, and I move my decimal 2 places, so it's 0.83. Move it 2 places. 0.09. Make sure it's 2 places. You're not just moving it to the front, you're moving it 2 places. Right? So I've moved my decimal on each one of them. Now we're going to set up a multiplication problem. So I'm going to do these in the same order. I'm just going to do it down here. So I've got my 49.9460 times 0.04345 equals. Okay, so I did my mass times the abundance. And I changed my calculator so you can see it. So 49.9460 times 0.04345 equals, and I'm going to go ahead and write out this whole number here, 2.1701537. Okay, so now I'm going to do, so I've done this one. So now I'm going to do the next one. So I have 51.9405 times 0.83789 equals. So in the calculator, let's do 51.9405 times 0.83789 equals 43.520425545. Okay, so I've done that one. So now I'm going to do the next one. 52.9406 times 0.09501 equals, so again the calculator, 52.9406 times 0.09501 equals 5.02988646, and I'm done with that one. And so now I do the last one, 53.9388 times 0.02365 equals, so let's put that in the calculator, 53.9388 times 0.02365 equals 1.275652262. Okay? Now, I'm going to add these up. That is our next step, is to take all of these numbers and add them together. So we're just going to add them up. So I'm going to go ahead and take the time to type it in the calculator. 537 plus 43.5204.25545 plus 5.029886406 plus 1.275652662 equals, now my calculator gives me 51.996118271. So again, last thing, always round it to 5 digits. So 1, 2, 3, 4, 5 digits. These are my 5 digits. This one is less than 5, so those just go away. And that stays that. So there's my answer. My answer is 51.996. All right? Now, I didn't tell you what element this was, but if you looked at the periodic table, you could find what element that is. That is the mass that is on the periodic table. We are going to do another example. This one's going to be very similar to the one that we just did. Decimal 2 places to the left for each one of these. 1, 2, 1, 2, 1, 2. All right, so I have 0.0056 and 0.0986, 0.070, 0.8258. I'm going to do this one slightly differently than I did the last example, in that I'm not going to rewrite everything down here. I'm just going to go straight across. So we have our mass times our abundance equals our number. So I'm going to do that for each one of these. So let's go ahead and get our calculator out, and we're going to do 83.9134 times 0.0056. And that gives me 0.46991504. All right, so that's the first one. Now the second one, I'm going to do 85.9093 times 0.0986. So mass times the abundance. And that gives me 8.47065698. And I do the next one. 86.9087 times 0.070 equals 6.083609. All right, and the last one, I have 87.9056 times 0.8258 equals 72.59244448. Okay, so I've done my mass times abundance for all of my isotopes, and now I'm going to do the last part of adding all of those together. So I have this one in my calculator, so I'm just going to leave it there and do plus. I'm going to go up here, 6.083609 plus 8.47065698 plus 0.46991504 equals. So all of that together adds up to 87.6166255, and I want to round this off to 5 digits. So that's 1, 2, 3, 4, 5 digits. I look next door. This is bigger than 5, so these go away, and this one gets rounded up. So my final answer is 87.617. So that is the atomic mass of this particular element with these isotopes. So those are all the examples I'm going to do here in the video. If you have questions when you're doing your assignment, please ask. If you're online, give me a